Hello students, I am Gaurav Agrawal, Senior Assistant Professor in Department of CSE Data Science at ABES Engineering College, Ghaziabad. Today in this lecture, we will discuss how to implement single linked list in C programming. Let us start our discussion by defining the linked list. A linked list can define a collection of objects called nodes. Linked list is defined as a collection of objects called node. A single node in linked list has two fields. One is the data field and another one is the link. Linked list can be represented as follows: contain a data field and a link field. The field contains the of the node and the link contains the address of next node. Linked list contains various nodes, each node containing data field and a link field, and this first node is the link part of the first node contains address of the next node. Similarly, the address part of the second node contains the address of the third node, and so on. And the last node, as it is not pointing to any of the list, it contains null. Are stored as these nodes are stored at random location in main memory. We have to store the address first node of the linked list in the pointer variable, and this pointer variable is generally termed as start. So the start contains the address of the first node. To create a linked list in C programming, first of all, we have to define the structure of the node, define the structure of the node. Next, we have to dynamically allocate memory using malloc function for the node. And in the third step, once the node has been created, we have to attach the node or link the node in the linked list at the end. Let's see these three steps one by one. For defining this structure of the node, we will be using the structure. To create such a node in C programming, we will create a structure which is being created by the struct keyword. Suppose we have given the tag as SL. As our node contains two fields, we will define two fields in this structure. The first field is of integer type that will contain the data, and second field is the link field that will store the address of the next node of the linked list. So this will be a self-referential pointer. So using the type def, we will assign a new name node to this structure. In our C program, this node will act as a data type. Once this structure has been declared, we will use the malloc function to allocate the memory, dynamic memory for a single node. Malloc function takes an argument as the size to be allocated. So we will use the size of function to return the size equivalent to this structure defined. So we'll be passing node. This will return a void pointer of the size equivalent to the size of the node. So we have to typecast it with node type, and it will be stored in the node type pointer variable. Suppose new. This new would be the node type, pointer variable. Once the structure has been defined, the memory for the new node has been defined. Next step would be we have to attach the nodes in the form of the linked list. So there would be two cases. Initially, when the linked list is empty, the start pointer would be containing null, indicating that there is no node or our in the linked list, or our linked list is empty. Whenever the first node arrives, we have to change the value of the start pointer, and this start pointer will start pointing to the first node of the linked list. As the first node is being created, the start will start pointing to the first node. After this, whenever a new node is being inserted, suppose this contains 10, and initially this is the only node, so the linked part of this node would be containing null. When the second node arises, start would be pointing to the first node, and the second node will be inserted at the end of this linked list. So this time we have to update the link part. Suppose this is the newly created node with data value, suppose 20. So this has to be attached with this one node linked list, and the link part of the first node will be updated to point to this second node, and so on. Let us see this procedure on our Visual Studio code. Let us code. First of all, we have to create the structure. To define our node, type def keyword. We will be declaring two fields in the structure, int data field and the link field. And we will assign a new name to this structure node. Once the structure has been created, we will write our main function. Within this main function, we will create some variable. First of all, let us declare a new variable that will be storing the address of the newly created node, which is being initialized to null. A pointer type variable of type node PTR that will be used to keep track of the last node inserted within the linked list, and a start pointer that will be holding the address of the first node. So first we will dynamically allocate memory for the node by using the malloc function. Malloc. Within the malloc, we will pass the size of, that will return the size of the node as we have discussed. This will return a void pointer, so we have to typecast it with the node type, and this value returned would be stored in the variable new. That means this malloc will return an address, of the size equivalent to the size of the node, which will be containing the data field and a link field, and that address return will be stored in the variable new. Now, to create the node, we do require the data field. So we will ask from the user, enter the data of the node. Let us declare this variable. Once the data has been entered by the user, we will insert this data value in the data field of the node by new data equal to value. Create the link part of the node to null. This will create the node having a data value well and the link part as null. Now this created node will be inserted in the linked list. So if this is the first node, we have to update the start pointer. So first of all, we have to check if this is the first node. That means if your linked list is empty, your start would be pointing to null. If start is equal to null, in that case, your linked list is empty and we have to update the start with the address of this new node, which is being stored in the pointer variable new. So we will write as start equal to new. That means start will be contain the address of new. And we have used a pointer variable ptr that will be pointing to this newly created first node. Else, if it is not the first node, we will update the link part of the last node with the newly created node and update the ptr with the new node. So what we have done here, we have updated the link part of the last node with the newly node, and our ptr would now be start pointing to the newly inserted node new. To display the linked list, we will create a function display, and in that function we will pass the start pointer. This whole task has to be repeated many times until the user do not want to enter any new node. So we will ask the user whether they want to enter new elements. If yes, so we will include this whole function in the do while loop. Let us also declare a variable for storing the choice of the user. So this whole code has been enclosed in a do while loop. Let us write the display function. We have passed the start. For displaying the linked list, we will start from the first node. Let us declare a pointer variable ptr. This ptr will store the address of the start passed from the main. Let us display the message printf created linked list. Let us start printing from the first node. So we will traverse the linked list starting from the first node to the last node. So while ptr, as we know, the link part of the last node contains null. Within the while loop, we will use while ptr is not equal to null, we will print the data and move forward. So within this display function, we have written this while loop. This while loop will traverse the linked list starting from the first node, print the data of the first node, and then update the ptr with the address of the next node. Now ptr will be start pointing to the next node and so on. This while loop will terminate when the ptr value of ptr will be equal to null. As the link part of the last node contain nulls, this loop will be terminated in the last. Let us run this program and see the output. Our program has been successfully compiled. It is asking for the enter the data for the node. Suppose we enter an integer value 10. The output shows that linked list is created with the data value 10, and it is asking for the user, do you want to enter the new element? If we press yes, why? Then it will be asking for the second value, that is, suppose we enter 20. The linked list created is 10 and then second element is 20. Again, it is asking for the new element. Suppose again we press Y for yes, we have to enter the new value. Suppose this time we enter 50. The newly created linked list contains 3 nodes, 10, 20, and 50. As we press N for no, our program will terminate. Let us revisit the program once again and see what we have done very quickly. First of all, we have defined the structure containing 2 data fields. One is the for the data and one for the link field. In the main function, we have created a node dynamically allocated memory for the node using the malloc function in line number 17 and inserted the value in the node in the data field and the link field we have assigned null. Then 2 cases arises. If this is the first node to be inserted, we have to update the start pointer. Else we have to insert the node at the last. And in the display function, this will continue till the user enter yes. And in the display function, we have passed the start from the main, and starting from the first node to the last node, the linked list will be traversed and it will display the data content of the linked list. Thank you.